All right, today we're talking about rates. Yesterday we talked about ratios. Ratios and rates, very similar. Some of the time they look exactly the same. We talked about today that rates usually are ratios that involve time, but they don't always have to. We focus today on unit rates, and the thing that makes them special is that a unit rate is a rate that has a denominator of 1. So they gave us some regular rates: 3 inches of rain in 6 hours, or 70 miles in 2 hours, and we were supposed to take them and change them to a unit rate because in the days to come we're going to talk about using a rate or a unit rate to scale up or scale down in order to find what we need. So basically the idea of tonight's homework was to get a regular rate and make it a unit rate. I'm going to start on this example down here in number 10. Franco is making breakfast. He uses 36 eggs for 12 orders. How many eggs does he use per order? There's a couple of ways that we can think about this. Initially, the ratio or the rate is 36 eggs for every 12 orders. And so we can set that up. What we're thinking about is, if I want to change this to 1 order, how many eggs am I going to need to do that? That's our thought process. One way to think about it is that 36 over 12 is just a division problem. 36 divided by 12 is 3. If we don't know that, we can solve it with long division. Another way to think about it is as a fraction, simplifying a fraction. The fraction 36 twelfths. If we want to have a unit rate in this case, where the denominator is equal to 1, then we know that we've got to divide by 12, because the only way to get 1 is to divide 12 by 12, and whatever we do to the denominator we also do to the numerator, so we divide it by 12 also, and we get to 3 over 1, or just 3. And the way we would probably say that most of the time is just 3 eggs per order, per meaning 1. And so that's kind of the thought process that the student should be going through in order to take these rates and turn them into unit rates as a denominator of 1, or something per something, so many eggs per order, or so many hours per day, or whatever the problem is asking for. Another example in number 2 up here, sometimes you will have a unit rate that doesn't divide evenly. So in this example, we divided evenly 36 by 12 to get 3. In this example here, 46 toys for $5, it's not going to divide evenly. Our $46 to 5 toys, when we divide that by 5 to make it a unit rate, 46 divided by 5, as you can see in the long division here, turns into a decimal, 9.2. And since we're talking about dollars, we're going to place a 0 in the 10th place so that we can correctly say this as $9.20. So our unit rate for $46 for 5 toys, our unit rate is $9.20 per toy. And so not a hard process really for students to do, just need to think about getting it to a denominator of 1, and this is kind of a prerequisite to talking about scaling rates up and scaling rates down. It's kind of a prerequisite to proportion, things that we're going to be talking about in the days to come. So each one of the questions on the homework tonight could be solved using the logic shown here in these 2 examples. And good luck on the homework, and we'll see you soon. Thanks for watching.